Good morning. Before we start, I've been noticing that I think I have a new catchphrase, and it's alright so, because every single time I start a video or I start a problem, I have to start out by saying alright so, and I don't know why, guys. It's just something that's gonna stick, I guess, and I can't change it. But today we're gonna do properties of rhombi. So, that is super big. So rhombi are just like, that's the plural form of rhombus. So don't say rhombuses, that's not correct. It's rhombi. And what you're going to notice is the rest of the quadrilaterals that we're doing are all going to fall under parallelograms. So knowing those 5 properties of a parallelogram that we went over all last week are really helpful because, again, it has all these same properties as a parallelogram and then plus 3 more. So the 3 new ones are going to be all 4 sides are congruent, and the diagonals are perpendicular. Hopefully we remember what perpendicular means. That means where they meet, they're forming a right angle. Okay, so like if you look at this rhombus down here, that would be a right angle, that would be a right angle, there's a right angle, and so on and so forth. And the last property that's kind of new are that the diagonals, one, they're bisecting each other, but they're also now going to bisect the angles. So bisect opposite angles. And we'll see how that comes into play with some of these problems. So today's going to be really easy. I'm actually going to go through all 5 of these problems with you. But if you want to stop after, like, if I do number 1, then maybe you try number 2 on your own. Or maybe 4 and 5 you try on your own. I would highly recommend that because then you're getting in practice and you're not just mindlessly listening to me, okay? So in number 1, I have JK is 12. So JK would be this side, 12, and JN is 7. So JN is going to be blue. Okay, so what do we know about rhombuses? Well, we know that all 4 sides are congruent. That's this new property. All 4 sides are congruent. So JK should be congruent to KL, LM, and JM. So right now, if I want to find JM, JM is one of those outside sides of the rhombus. So JM is also going to be 12. JL. JL is this whole diagonal. Well, again, we know that the diagonals are bisecting each other. So this same thing holds true, that this diagonal, this half of the diagonal should be congruent to this half. So a half plus a half, I'm going to take 7 and double it to get this whole diagonal. So 7 times 2 gives me 14 for JL. Okay. Next thing I know is MN. So again, we have a part of a diagonal. So MN is here. And we know that all 4 sides are congruent. So what it's making is actually this would also be 12, which I need. Hold on. Sorry, I lost my train of thought. So this is 12. We don't actually know if this diagonal is congruent to JL because this isn't a rectangle and we don't have the diagonals are congruent. We just know that they're perpendicular and they bisect opposite angles. we don't technically know that the diagonals are congruent like we did in rectangles. Okay, so if you want to go ahead and put m in as 7, that's not always going to be correct. Instead, what we know is that these diagonals are perpendicular to each other, so we now have 4 right triangles within this rhombus. So if I just look at this triangle right here in yellow, I have a right triangle. So I'm going to use Pythagorean theorem. 7 could be my a, so I have 7 squared plus, if I'm finding m in is going to be my x, what I'm figuring out, equals, and then 12 is my hypotenuse, so 12 squared. Okay, so then I have 7 squared turns into 49 plus x squared equals 144. Subtract 49, and I get x squared equals 95. Take the square root, and you get x equals 9.7, so I'm just going to make it 9.7 instead of keeping it as square root of 95. Okay, so you're going to have to use Pythagorean theorem in these as well. Just so you know, anytime you're talking about perpendicular angles or right angles, you're probably going to be using right triangle properties, so like using Pythagorean theorem. The last side that we're finding is MK. MK is this diagonal. So again, we don't know the diagonals are congruent, but we do know they're bisecting each other. So MN should be congruent to NK. NK, MN are congruent. So since MN is 9.7, I'm going to take MN and multiply it by 2 to get MK. So 9.7 times 2 equals 19.4. I'm going to erase some of this stuff. So in 2, I know that EF is 23. EF is this outside side. And DF is 40. Okay, so with GF is one of the outside perimeter sides of this rhombus, so that's going to be congruent to 23. So GF is also 23. HF is half of this diagonal in DF, so I have to think of what's half of 40 because these diagonals are bisecting each other. So half of 40, I would get 20 for HF. Next I'm finding GH. GH is part of this other diagonal. So let me get rid of 40 for a second. Because I know this is 20. Oops. And this is 20. Okay, those are congruent. And then these two sides of the diagonal would be congruent to each other as well. I just don't know what they are yet. So GF is this part of the diagonal, but I know it's going to be congruent to EH. So I could figure out what EH is by just looking at this triangle right here. This is a right triangle. So again, I'm going to use Pythagorean theorem. 20 can be my A. This will be my B, so I'm going to make my B my X in my equation so I can solve for X. And then EF is going to be my hypotenuse. So A squared plus B squared equals C squared. So 20 squared plus X squared equals 23 squared. When you square 20 and subtract it from 23 squared, you get X squared equals 129. Then you're going to take the square root of both sides, and X equals 11.4. So really the only time you guys should be getting decimals is when you're doing Pythagorean theorem. It doesn't always have to be a decimal, but for a majority of the time, you're probably going to get a decimal. So don't freak out if you do get one. It's normal because not all of these are going to be like perfect Pythagorean triples. So really what I found was EH, but since I knew that EH and HG are congruent, that just makes HG or GH 11.4 as well, because they're both half of that diagonal. So then GE would be this whole diagonal. So if I know each half of this is 11.4, I'm going to take 11.4 and multiply it by 2. So 11.4 times 2, and I get 22.8. So GE is 22.8. Okay, 3 is a lot like 1 and 2, so if you want to try this on your own really fast, I'd pause it. And now I'm going to keep going. So RT is 22. RT is this diagonal. And US is 18. US is this other diagonal. So now we're only told something about the diagonals, which is fine. But already looking ahead, if I know what this whole diagonal is, if I want to just figure out what RV and VT are, I'm going to take RT and divide by 2. So that means RV is 11 and VT is also 11. Then if I look at my green diagonal, US is 18. So again, I'm going to divide US by 2. And so that means this part is 9 and this part is 9. So now that's going to help me with the rest of these. So VT, I already found that. That's half of the full diagonal, so it's 11. UV is half of this green diagonal. We said the green diagonal was 18, so half of 18 gives me 9. And then RS is actually one of the outside sides, which we weren't told. So we're going to have to use Pythagorean theorem again to find this RS. And if you don't see that right triangle, I'm going to kind of highlight it. Yellow. Okay, so 11 and 9, those can be my A and my B. And then really what I'm finding is my hypotenuse. So I'm going to have 11 squared plus 9 squared equals x squared. And x squared is that RS side. So 9 squared plus 11 squared gives me 202. When I take the square root, I get x equals 14.2. So RS is 14.2. Now I'm looking to find what ST is. ST is just another side on the outside of that rhombus. So whatever RS is, that should be the same for ST because all the sides are congruent. So ST is also 14.2. Number 4 gets into more so just the angle measures instead of the side lengths. So with this one, I can already tell we're going to use a lot of the fact that the diagonals are bisecting each other. We're going to use some alternate interior angle stuff, and we're going to use the sum of the angles within a triangle add up to 180 degrees. So those are the 3 big things that I see already that we're going to be using. Starting off, we're given that this angle is 38. So I can already find an angle that should be congruent to 38, and that would be angle 4. The reason why would be those alternate interior angles. Okay, so angle 4 I can already say is 38 degrees. Right, the next one that I think is pretty easy to see would be angle 8. Angle 8 is right where those two diagonals are meeting, where they're bisecting each other. And one of the properties of the diagonals is that they're intersecting each other to form, they're perpendicular to each other. So when they're intersecting, they're forming that right angle. So measure of angle 8 is 90 degrees. Now I'm going to kind of have to fill in some things. So if I erase this right angle, because angle 8 is a right angle, and these diagonals are perpendicular, that also makes this angle right here a right angle. And I know angle 4 is 38 degrees. Kind of draw that in there. So now I can figure out angle 2 pretty easily by doing triangle sum theorem, because angle 2 plus angle 4 plus this 90-degree angle should add up to 180, because this is a triangle right here. So I'm going to take 180 and subtract 90 from it and 38 to get that remaining angle 2. Okay, and I end up getting 52 degrees. So angle 2 is 52 degrees. The other cool thing about rhombuses that we haven't really talked about is that these diagonals, wherever they are intersecting the angle that they're going through, so like this diagonal is intersecting 7 and 6, and then 1 and 2, what they're doing is they are bisecting the angle. So bisecting an angle means it's splitting it up into two equal parts. So whatever angle 2 is, angle 1 is as well. So if we know angle 2 is 52 degrees, that means angle 1 also has to be 52 degrees. So that was easy to find. Using that same idea down here, angle 3 and this angle that's measured to be 38, those should both be 38 degrees, because again, this diagonal is bisecting that angle. So angle 3 is 38. And if we look to this angle as well, angle 4 and 5 should be congruent as well. So angle 5 is also 38 degrees. And 6 and 7, they turn out to be pretty easy as well. If you wanted to do the sum of the angles in a quadrilateral, you could do that. Or you could just use the fact that this diagonal is intersecting both of these angles. So it's making 6 and 7 congruent to 1 and 2. And you can see that as well by doing alternate interior angles. Angle 2 is an alternate interior angle to angle 7. So 2 and 7 should be congruent, and then that makes 6 congruent to 7 as well. So angle 2 is 52 degrees, so angle 6 and 7 should also be 52 degrees. All right, last one we're doing, and I'm going to kind of have to, I don't know, I can't really zoom very well with this one. Hopefully you guys can see that. So with this one, I'm doing the sides and the angles, so this is kind of mixing everything in at once. So hopefully we don't get too overwhelmed, but stay with me. So ZY is 34. So ZY, that's one of the sides. And if you want to just start with just doing everything with the sides, that's perfectly fine. I would actually recommend that, because then you're not mixing up too many things like, oh, when do I use Pythagorean theorem versus the sum of the angle measures equals 180. Like, I know we mix that up a lot, so we're just going to start with the side measures, and then we'll talk about the angle. So WY is one of those diagonals, and it is 38. So we know the diagonals are bisecting each other. So again, I'm going to mark that WV is congruent to VY. But both of those, if I add them together, they should equal that 38. So now looking at what I'm trying to find, WZ. So WZ is just one of the outside sides of the rhombus. So since one side is already 34, I know that all of these other three sides should also be 34. Next is VY. VY is half of this diagonal. Since I know this whole diagonal is 38, I'm going to take half of 38. So whatever 38 divided by 2 is, which is 19. So that means this part of the diagonal is 19, and as well as this part of the diagonal, because they are congruent to each other. Then ZV. ZV is this part of the diagonal, ZX. I don't know if these diagonals are congruent. Do not mix this up with rectangles. So I'm not going to say it's 19 because I don't know that. Instead, I'm going to have to use Pythagorean theorem because this is my right angle. So if I know I'm trying to find this black side, I'm going to call it my X. I have my hypotenuse. My hypotenuse is 34. So I'm going to have x squared plus 19 squared equals 34 squared. X squared. Okay, so when you take the square of 19, subtract it from the square of 34, you get x squared equals 795. Take the square root of both sides, and x equals 28.2. Okay, if you did not get x equals 28.2, stop. Make sure you're setting up your Pythagorean theorem correctly and putting everything correctly in your calculator. So that means ZV is 28.2. Next, I'm finding ZX. So ZX is this entire diagonal. So if I know what 1/2 of the diagonal is, I'm going to double it to find the whole diagonal. So 28.2 times 2. And I get 56.4. Alright, so that's just the side. So I'm going to actually erase everything so I have more room for finding the angle stuff. If you're doing this on a blank sheet of paper or actually on this sheet of paper, you should maybe right below here, you can just draw another rhombus. That might make it a little bit easier than trying to like write over all the sides. My turtle is still making some noise. With the angles, the only angle I'm given is ZXY. ZXY is this angle right there. And ZXY is 34 degrees. I'm actually given more angles than that. Reminder that these are all 90-degree angles in the middle here, where those diagonals are bisecting each other. And then also, since the diagonals are bisecting all of these angles, that means this angle, and this angle should all be 34 degrees as well. So that might come in handy. The first angle we're finding, however, is WXZ. WXZ, that's going to be this angle right here. So the one right next to the angle we were given, making those two congruent to each other since this diagonal is bisecting that angle. So it's also going to be 34 degrees. The next angle is WVZ. WVZ is actually this right angle. WVZ right here. So WVZ is 90 degrees. And then angle ZYW. ZYW is this guy right here. I'm going to make that green. We do not know what that angle is just quite yet, but we do know that this angle right next to it should be the same thing. So I'm going to make that a little bit darker. So I made them kind of two different colors. One's highlighter and one's just a marker. But since they're both green, we're going to act like they're both the same thing, okay? So if I know this angle is 34 degrees, this angle is 90 degrees, I could figure out this green angle by doing the sum of all the measures in a triangle, add up to 180. So I'm going to take 180 minus 34 minus 90 to get that last angle measure that we're missing, which turns out to be 56 degrees. So this angle is 56 degrees, and since these angles are right next to each other and one of those diagonals is bisecting it, it's going to make those two congruent. So angle ZYW is also 56. Last one, XYW. XYW. Okay, so we already found that one. So that's just 56 as well. All right. So that's all I have. This video had to be very, very short. If you look on the worksheet, it gets into the properties of a square next. I don't want to do squares just quite yet. I think that would be too much for today and with online learning. So we only want to do rhombi today. I'm going to have a few short questions for a quiz today just to show that you logged in and watched the video. Keyword, we're going to have a keyword. So keyword is, oh gosh, what should it be? Oh, it should be all right because I know I say that a lot. So keyword, all right. Okay, so you're going to need that for your quiz today, just so I know you watch this video and are following along. If you have any questions about rhombi, I cannot say that right now. If you have any questions, let me know, and I can try to help you out if my video didn't make any sense, or if you want some more practice. But tomorrow we will get into squares, hopefully, and then Friday we're going to kind of combine them, okay, right before spring break. So only like 2-3 more days, however you want to look at it. I'm going to look at it as just like 2 more days, all right? Those of you that are on the cusp of failing, so maybe you're at like a 61, or not 61, like a 70 or 71, you have to stay with me. You cannot just give up right now, okay? I know we're on year-long grading, so it seems like the grades I put in right now make no difference whatsoever, but they actually can if you just stop working. You can get yourself in quite a hole, and it can be very, very hard to get out. Those of you that are really, really close to passing, you have to be doing everything you can to be getting either a 90 or 100 on all of the quizzes that I give you. If you don't, you need to ask me to be reassessing something because it's getting very, very close to the end, and I don't know if we're going back to school. I don't know how much more time we'll have to bring these grades back up, okay? So I just want to make sure you're prepared and have everything you can to pass this class, okay? But yeah, that's all I got. If you are worried about your grade at all, reach out to me though, okay? That's all I got. I'm going to stop rambling. Have a good day.